I don't think anyone's ever done something this extreme before. We had a lot of concerns about the shape going in. We had concerns to the point where Chris and the team at Roval actually asked me to make backup shapes. I do hundreds and hundreds of CFD runs to find the best shape. The wider I made that flat back, the faster it got. And it was pretty crazy what you see on the finished wheel. That was the absolute fastest shape. And the concern was, can we make this? Can we make this and can we make it past testing? At the end of the day, like, no one wants to leave that performance on the table, right? You don't want to make the third fastest wheels that you could make. You want to make the fastest.
Lio, having come from what we designed on repeat and sprint around deeper front, shallower rears, said, hey, we're gonna need a super deep wheel. And that's just not gonna work for a lot of gravel racers. So, he came up with this idea of like, hey, we basically want a 70 airfoil cut at 50. We're gonna get most of the performance, this super truncated flat top. It's gonna look awesome. It's gonna be great air performance. We do it in CFD. Everybody loves it. Phillip on the engineering side is looking at this, like quiet in the back, just like, gosh, shoot, like this is like near impossible. Crap, I have to make this thing work.
Yeah, initially ignorance is bliss. You see it, and the optimistic side of you of being an engineer, you're like, okay, here's a problem, I'm going to solve it, and everything's going to go right. Or maybe not everything's going to go right, but we're going to get it solved. But definitely once you get into manufacturing, there's definitely some challenges to work through.
We would generally call this a truncated airfoil, right? So when you think of an airfoil, it's kind of gradient inwards. There's a maximum angle you can keep the flow attached to the wheel, bringing it in. So the issue we run into with these gravel tires is a geometry problem, right? You can only bring it in so quickly, and we wanted to keep this at a mid-depth wheel. We didn't want this to be an 80, 90 mil wheel. So what we did is we just truncated the airfoil, and that's the crazy shape that you're seeing.
One thing that's unique to a blunt trailing edge is then you're left with a very abrupt transition from the sidewall to kind of the flat portion. Then, yeah, as we have this, like I said, this abrupt transition, then all of a sudden you have to start fine-tuning the build parameters to make sure that we really mitigated any sort of risks associated with that higher load state. As we move to these larger tire sizes that are inherent to gravel, then to follow the same kind of methodology that we've used on road, it would have resulted in a rim shape that really is quite deep, and we would have been penalized quite heavily on mass. This flat trailing edge really enabled us to have our aerodynamics and have our mass too.
Aero has become a huge aspect, a huge growing topic in gravel, right? As gravel gets more and more professional and more competitive, speeds keep going up and up. And as we all know, the faster you ride, the more important aerodynamics becomes. As a gravel racer, almost all the resistance you're fighting against comes from aerodynamic drag. It's not rolling resistance, it's not your bearings, it's not your chain. Almost everything that you're fighting against is the wind. So if someone can cheat the wind better than the next guy, that's a really big advantage.
Initially, maybe aerodynamics wasn't the main priority, but as we're getting further along, it becomes more and more important to have something that's very competitive in terms of aerodynamics. That formed the basis of this project, where, okay, let's really take the learnings from Sprint and Repeat 3, and let's design a very fast product for gravel.
The evolution definitely gone more road-esque in a lot of ways, but then at the same time really taking in a lot of the considerations from the mountain bike side around durability, ride quality, lightweight. So it was pretty clear to us from almost day one that we're going to need two different wheels. And what we wanted to do is have a foundation of features that were synonymous across both that would just give our athletes an advantage. So we knew we wanted to be really optimized around a larger tire, 45s into 50s, but we also knew that we have to have pinch flat protection. We have to have increased durability. Courses are only getting harsher. They're pushing hard. They're riding in packs. They're going to hit potholes. So like the durability of the wheels needed to go up.
Pinch flat is potentially an aspect of design that's maybe not as prioritized outside of Roval as maybe as serious as we take it. We believe making a fast product is not just about aero or mass, but also durability. You still need to make it to the finish line, right? Regardless of what sort of problems you encounter out on the course.
As part of this project, we actually went back and reevaluated our gravel impact standards, our gravel blow-off standards, and redid all the work we did to make sure the impact, high energy, low energy, those big bumps, little bumps, fatigue, disc brake, all those things were, again, rechecked to make sure that, again, we're staying at the cutting edge of what it means to be the most durable wheel brand out there.
When we're looking at a rim, it's not just the rim, it's not just the spokes, it's not just the tire, it's a system. So you really have a unique combination of different loads with tire pressure and also different strength with the rim shape that make it a little bit challenging to make sure it passes all our same test requirements as opposed to something like mountain or even road, where it's really this complex interaction of all these different kind of unique components.
Being at Specialized and Roval, we have this access to the best athletes on earth. The depth of time I spent with Sophia and Matt and the relationship and the feedback that they've given and influence they've had on the products, which is just huge, is really appreciated. We can't make great talking about them.
We actually have a group chat with the athletes that we're in, and it's really cool. Their first time on the wheel, I remember, I think it was Sophia texted us back and she was like, hey, can you guys please let me use these at Worlds? Can you guys please let me use these at this next race?
I was trying really hard to convince Brad to let's bring the wheels, have them as the backup of backup. So let's say I flat for some crazy reason, I have a mechanical and I have to chase 1 minute for the unbound win, and it could be the wheel that would make the difference. I was like, I bet you, in that crazy scenario, should we get into really big trouble to try to win, So Brad was like, no, I'm just not even bringing the wheels because I know you're gonna try to race them.
Sometimes from Chris, I hear oh, in this WhatsApp group, Matt Beer said this or Sophia said this, and then some reporter will get a snippet and see the product out in the wild when we haven't made official announcement. And I know, yeah, that's maybe frowned upon, but then deep inside, then you're like, oh, that's kind of cool.
That Belgian waffle ride, that was our first outing on the wheels, and came down this one single track section and just absolutely nuked something. I was like, oh goodness. And then behind me I think 3 guys flattened that hit the same thing. I was like, well, I guess there we go. I'm gonna never go off of these now. They've saved me multiple times. I don't know how I haven't flatted. It still baffles my mind. I put equipment through the ringer, and if things don't break and I don't complain and no one hears from me, I think it's a pretty good sign. So having access to equipment that can take all these beatings and how I ride in my ways has been super crucial. That's what we want, as riders. That's absolute gold.
Specialized is the type of company that they like to excel and have the perfect equipment, and as an athlete it's nice to have the options to be okay, if it's going to be a race that I want to attack and be solo, I'm really going to prioritize the aerodynamics. But if it's a race that I think it's going to come down to an short acceleration attack into the finish, then maybe I want to have something that's lighter weight. Am I the most engineer savvy? No. I am the type of rider that I'm give me the product and I'll tell you, does it feel good, does it not feel good? And I do remember just feeling the speed that I would go test the aero wheels and then go back to my standard ones. It's I can feel the difference, which says a lot of just how much faster those wheels are.
For us, right, it's thrilling. That's what drives us every day, is how can we help our riders and our products be faster? For me, cycling is very good parallels to Formula One, right? It's how can we have that union of human and machine for the optimal performance in a race situation? How can we get an engineering solution for a human athlete that helps them win?